So today we are going to learn about important points regarding on resistor. This chapter comes really 4 to 5 questions in every competitive examination. So thorough in this chapter will help you to score 4 to 5 marks in competitive examination. So I will discussing the important points on this chapter as well as some few in previous year paper also, so that your concept gets clear. Here you will be going point to point, no wastage of time, quick revision in a short time. So without any further delay, let's get started. Important points. A resistor is an electrical component that limits or regulates the flow of electric current in an electronic circuit. Unit is ohms and symbol is this. Basically, it is a resistor is opposition to the flow of electric current. Any current flows, resistor will oppose. That is, it's a property. That is what this meaning says. And higher units are kilo ohms, mega ohms, etc. Next, an electric current is a movement of free electrons predominantly in one direction. Predominantly means in one direction, particular direction. So I is equal to dq by dt. Unit is ampere or coulombs per second. Remember this, they will ask directly in this examination question. The flow of electric current in a conductor is due to electrons. In semiconductor, it is free electrons and holes. In electrolytes, positive and negative ion. In gases, electrons and positive and negative ion. Moving ahead, you have different types of resistors. Can have a go through of the chart: linear, non-linear, non-linear resistor, linear resistor, linear fixed and variable, and carbon wire wound, fusible, metal oxide, carbon film resistor, and non-linear thermistor, LDR, VDR. All you have to have, just go through and keep this so that they directly ask in the examination, so you can clearly mark the answers without any confusion. And this and all will be discussing later in transducer type of chapter. So time being, you will go through this figure. Next comes resistor color code. This is a very important topic. Normally color code will, many people will get confused to write the color code in the examination. They'll give direct problem regarding that, and many people will get stuck in that. So here I'm giving a simple way of for you to write the color code. Have a look on the chart. So everybody knows this is black, brown, red, orange, yellow, green, blue, violet, gray, white, gold, silver, none. So in this color, this is a color, and this color represent in first band this value 0, 1, 2, 3, 4, 9 up to white respectively. Similarly, second band, third band also same thing. Fourth band comes in multiplier. Fifth band also comes in multiplier. Next tolerance, last is temperature. That is for 6 band color code. This 6 band color code only is applicable. Normally they will ask in exam 3 or 4 band color code. So if you remember 3 or 4 band color code, it's a sufficient for your examination. So I will discuss few examples so that your concept will get clear in this. Uh, 1 minute. Brown, black, red. Remember this is a 4 band color code, and last is 3 band color code, sorry, gold. So this is a 4 band color code, And here it is brown. Brown value is in the product is 1, black is 0, red is 10 to the power of 2. When comes red, it you have to get multiplier. And gold is plus or minus 5% tolerance. So the value of this is 1000 ohms plus or minus 5%, or is equal to 1 kilo ohms plus or minus 5%. So this is the answer for this. I'll mark a highlighter on this for getting a better clarity. Here now one more questions they will ask. 1 kilo ohms plus or minus 5%. So what is the range on this? This plus or 5% is a tolerance. So they will ask 1 kilo ohms, what is the range of this resistor? So in that you have to have 5% you have to remove from this 1000. From 1000 5% is 50 ohms. So the range will be 950 to 1050 ohms. This is the range for this 1000 1 kilo ohm plus or minus 5%. I hope you are clear. Next example. Yellow, uh, yellow, violet, black, silver. So for this, yellow is the color coded band 4, violet is 7, black is 10 to the power of 0. So in comes it, you have to get multiply. Oh, just a moment. So silver is plus or minus 10% silver. So here the color code is yellow is 4, violet is 7, black is 10 to the power of 0. So how you write this? You kindly note this: 4, 7, 10 to the power of 0 is 1. Anything power raised to the power, anything number raised to the power of 0 is 1. That is a rule. So that is equal to 47 ohms plus or minus 10%. Must highlight this so that you are another example on this. So how do you write 5 ohms? 5 ohms. So that also I will explain you clearly. Green, black, green, black, gold, and here no color. So green is 5, black is 0, gold is multiplier of 0.1, no color plus or minus 20%. So this will have like this 50 into 0.1, so that is equal to 5 ohms plus or minus 20%. Just a moment. This is the answer for this. Like that you have to practice. And in the reverse way also, they will ask the question what is the color code of 47 ohms, or they will give some this type of questions. So vice versa you can able to answer in the examination. Let's move to next topic, Ohm's law. Ohm's law states that voltage across a conductor is directly proportional to the current flowing through it, and provided physical condition and temperature remains constant mathematically, V is equal to I. So here is equal to I is equal to V by R. So I is equal directly proportional to V. Here the formula, all the things are summarized with your clarity, so you can have an easy access for this. For current, I is equal to V by R. For other formula, P by V, and another part of divided by power by resistor. Similarly for resistor, V by I, V square by P, P divided by I square. Similarly for voltage, V is equal to I into R, V is equal to P by I, V is equal to square root of P into R. Similarly for power, power is equal to V into I squared R, and V squared R. So this law is very important in a competitive examination. They will ask directly which current is related to voltage or resistor or power, what is the relation between them, and sometimes few problems also comes in the examination. At that time you have a better idea, remembering of this all this formulas, current, resistor, voltage and current in a chart like this, your problem will be solved in the examination easily. So next, active and passive elements. See, what is it you mean by active and passive elements? Passive elements is which do not store any energy at all. They dissipate energy. For that is resistor, capacitor and inductor. So they do not store any energy at all. Just these are called passive energy. In that you can include transformer also. Transformer. You can include transformer also. These passive elements. Comes for active elements where the energy can store and get delivered to the circuit. Example, generator, battery, operational amplifiers, like this. And this is a symbol of AC, DC and battery symbol, independent source, and this is called as dependent source. Have through the kindly go through this chart, so it will be helpful for your examination. Next comes resistivity. A resistivity is defined as the resistance offered. Something is missing. I will write here itself. Resistivity is defined as the resistance offered by the material per unit length of for a unit cross sectional. The SI unit of resistivity is ohm meter. Resistivity increases linearly with temperature. Very important point. Directly competitive examination questions they will ask. So resistivity is equal to rho is equal to R into A divided by L. So rho is directly proportional to resistor. Just a moment. Directly proportional to resistor and area, and this rho is inversely proportional to its length. So this you have to keep note down the this type of relation things. Competitive exam they will ask the relation directly. What is what? R is the resistance of the wire, A is the cross sectional area, length, L is the length of the wire, R is rho is the resistivity. And some short trick formula is there. If the wire is stretched to n times, that is length, n times, the new resistor R dash will be formed by n square into R. If the wire is compressed, that is length is compressed by n times, the new resistance, original resistor divided by the compressed time. compress number of times, that is square of number of times. So this and all will discussing coming up. I have in a few previous year paper question so that your concept get clear on that. Next, resistor temperature. So this formula called resistance temperature formula. So you can have a thing, you can have how much temperature per degree the resistance is reached. So this is the formula for this. R naught is the temperature, alpha is the temperature coefficient resistance, T is equal to before temperature, T naught is after temperature. So this I will discuss in the problem for you coming up videos so that your concept get cleared. Next, the Ohm's law of conduction in metals is J is equal to conductivity E. This is the very important. J is equal to conductivity into E. I'll make a highlighter for this. Conductivity into E. J is the current density, sigma is the conductivity, E is an electrical field. Moves to Joule's law. When a current flowing through a resistor, it consumes energy and generates heat. This is called as Joule's law, and the formula is I square R into T. I is the current, R is the resistor, T is the time, unit is joules. And moving ahead, then comes Kirchhoff current law. So this law is very familiar to two laws are very important point of competitive use. Here written the sigma, I will give a clarity for you. Sigma n is equal to 1, n I r is equal to 0. This is known as KCL. That is current entering. Suppose this is the junction. Current entering into the junction, current leaving is same. That is no charge in the junction node. That it means sum of current leaving is equal to sum of current entering in the node. I1 plus I4. These are current entering. I1 and I4. This is current entering in the node, and I2 and I3 current leaving. So with this equal means net current will be 0. That's what Kirchhoff current law says. This law is very important while applying transistor biasing problems or network theory problems or transient analysis. So everywhere it is getting very important for you. So clear concept on this is a very important to solve the problem easily. And next comes Kirchhoff voltage law. This law also similarly state that sum of voltage around a closed path is, or sum of voltage drop is equal to sum of the voltage source. So this is the closed path. So this is the voltage source, and this voltage in a closed path, this 2 voltage is equal to this voltage. That is what this says. VDC is equal to V1 by V2. So this is what the thing. And how to write KVL, KCL, both I will explain when the problem comes. I will apply few problems in the coming up videos so that your concept will be clear. Clearly I will be explaining what is the step, how to do, plus or minus, even some basic concept also I am getting, so that you will be clearly understood and without any much difficulty your problem will be solved while attending the questions in your examination. Next comes current division rule. This is the one of the important to solve your current problem without much going through the complex resistor to solve. Then you put the formula is that I is equal to V by R. So you don't want to have this V voltage also, total resistance and voltage also on that. So you can directly uh, if you know the total current, you can directly solve this type of questions easily. Let's see how we are solving. See, current I1. So we want to find this I1. So current division rule says that where the current entering, if you want to find here the I1, you should consider the opposite branch opposite resistor branch. This R1 we want to find here means you have to consider this opposite branch R2. That's what is written, R2 and sum of these two resistor R1 R2 into total current. So you will find I1 current. This current you will get. Similarly for I2, if you want to have this current and you have to consider this branch R1 R1 divided by R1 plus R2 into total. If you do this, you will get I2 current for this. So without any much complication, competitive exam, this formula if you directly apply and take it means problem will be solved in just 15 to 20 seconds. Moving ahead, star delta transformation. So many books they have given some of the formulas. So I also have mentioned you here delta to star and delta to star and star to delta. So here the formulas I have kept for this. I will just give a simple explanation on this. More clarity will be done when I will solve the problem for you. So it will be in a clear. So here you see delta to star. So this is the node you keep it x. The same thing x. So you're converting delta this to star. Delta will normally they'll give like this. Star will be giving symbol y. Okay, right. Now you want to find this R1. Okay, so delta this node you keep it same. So to find R1, so you should have RB into RC. So this two. So from this node what is dividing these two resistor RB and RC divided by all the three divided by sum of all three resistor RB, RC and RA. This is what the R1 comes. Then for R2, similarly for R2, keep this Y node here. This Y node here comes as RC into RA. This is what here, and then sum of all RAB and RC. So this is what star to delta transformation. Sorry, delta to star transformation. Then again Z. Keep this node Z here, and from Z node, what is the two V shape of branch is going to see? RB and RA. RA and RB divided by whole sum of all the three resistor. Okay. The similar way, if you convert for star to delta, keep these nodes same, and you want this line, this line. That is, I'll give a dotted line on this. Probably I'll put another color ink so that you can have a clear idea. See that this is the thing. This two side. So this resistor, okay, or this resistor R1 into R3, then again R2 into R3 plus then again R3 into R1. This is the cyclic combination you have to take, then divided by this to the opposite resistor R2. You have to put R2. This if you want to find RB. So R1 into R2, R2 into R3, then again R2 into R1 divided by this resistor. If you are taking these two opposite resistor, these two, then again you are taking RC. You want to find RC, then this node, this two node you see. I am marking here dotted lines. This two node, R1 into R2, then same similar cycle, R2 into R3 and R3 into R1. Okay, then divided by, if you taking these two, then opposition is R3. Opposite term is R3 resistor, you have to divide. So like that, RA resistor also similarly you can find this. So I will be solving the problem. In that problem, you will be getting clear idea of the, suppose this all the things having 1 ohms, 1 ohms, 1 ohms. Okay, in delta, sorry, in star, RY star will be having R delta by 3. So what is R delta? Delta is 1 ohms and this is 1 by 3 ohms. So everything 1 by 3, 1 by 3, 1 by 3. Similarly, for R delta, if it is 1 ohms, so if it is 3 ohms, 1 minute, just a minute. So R delta is equal to Ry into Ry into 3. So Ry is equal to 1 over 3 and divided multiplied by 3. These three gets cancelled, 1 ohms. So like that, if the same value is there, you can calculate like this. Similar, that means all three resistors would be similar value. You can convert uh, delta to star or star to delta in this similar in the following manner. So with very simple. So by practicing that, you need not to touch paper and pen also while in attending competition. So you can in mind itself you can calculate and you can take the answer. Then you can move ahead to the other questions quickly. Uh, the overview I thought for you important points everything in point of competitive examination. Uh, Now again you will go to solve some of the uh, MCQ questions. Same thing came 1 minute. So some of the MCQ questions which I have given for you here, and one more concept also is there, Wheatstone bridge. This stone bridge is very useful to find unknown resistor, or you connect this type of bridge form and you vary this resistor, so then galvanometer current will be 0. By this null method you are finding that unknown value of a resistor. So this is the basic principle of concept. So this is the ratio is P by Q R by S here, P by Q R by S. So R you should find out P by Q into S. If you put this, everything you will get in resistor in ohms. So this is a very simple concept. Moreover, I will apply this concept in coming up videos in the problems, so that concept will get cleared for you. This is nothing but methoding null method. That's all. In the circuit you are making 0 and you are taking resistor, so it will be accurate for you. Coming to this question. So some of the important MCQs I have taken, which is getting really confused in examination, how to solve this in a quick and proper analyzation. By practicing this, you can have a quick approach in your examination without any difficulties. Let's start at this. For the circuit shown below, the current I flowing through the circuit will be I is I circuit will be. See, the diagram is connected like this. Suppose you mark this as A, B, C and T point. So this resistor, all this resistor, you kindly look the clarity. This point is directly connected. So that is, this is parallel to this and this also. So all three resistors are parallel to this. How you see that? I will draw here. I will take another color pen. I will take a blue color pen, so it will be an easy. See, A point, point A over, then you have to come by point B. Here it is point B. Okay, this point B, you see that it is directly connected to D, and this C is connected directly A. So here the point is B. This B, I'm talking about, I'm talking to this resistor. This resistor C. This B and is here itself, and this C is C, you directly connected to this. So that this resistor comes like this, you see. It's directly connected to A. Understood? This point A is directly connected. So here one side of the resistor is B and another side of resistor C. This is the C. Here point is C. Then again this C point resistor is directly connected to D, and this D is directly connected to this B. So again one resistor to this here it's D point. So all the three resistors are now parallel. Just a moment. Diagram is not clear. I will write some clear diagrams for you. A, B. Then the C is joined directly to A. So this point is already there, and this is C point is directly to A, and from C point one resistor comes to the D point. This is the D point. C point, one resistor directly comes to the D point, and this D point is connected to B. It's already connected in B. Then circuit get completed like this. Plus minus 12 volt. Now the values are 3, 3, 3 ohms each. Just a moment. Twelve volt, 3 ohms, 3 ohms, 3 ohms. Okay. Now all three are in parallel. So 1 by RT. This is a parallel formula. 1 over R1 plus 1 over R2 plus 1 over R3. So here is 1 over RT, 1 over plus 1 over 3 plus 1 over 3. So here they are asking total current. So for that current, the formula is I is equal to V by R. So we are finding total resistor R right now. V is all three combination in parallel combination. All the three ohms resistance will have 12 volt common for everybody. In parallel combination, all three all resistor same voltage will be available. Current will be different. Very important point. Keep this in mind while solving the problem in examination. So in parallel branch, voltage all will be same. Current will differ in each branch. So here they are not asked individual branch current. Here they asked total current for you in this year. Total current. So this total current, to find this, first you have to take the resistor R. Yes. So 1 over RT, 1 by 3, 1 by 3, 1 by 3. So that is equal to 3 by 3. LCM will be 3, and 3 by 3 is equal to 1 ohms. Then RT is equal to 1 ohms. Cross multiply on this. RT into 1 and so 1 ohms only. Then I is equal to V by R. So 12 volt by R. 3, 4 answer. So here where it is the 4 amps? The D is the 4. D is the right answer. I hope you are clear in this. Mark on a highlighter. Just a moment. So 4 amps is the right answer for this. Then moving to this question. This is one of the important question in many competitive examination. you will see this type of questions, and it is very simple, very simple. Initially I will tell the concept, what is the concept on this. You have to apply the KVL in a loop, then you have to get. So the question what they are asking, 12 1 ohms resistors are used as edge to form as a cube. Cube will be having 6 faces, 1 2 3 4 5 6, bottom also 1. Okay, the resistance between two diagonal opposite. The resistance between two diagonal means opposite side, this side as well as this side, opposite diagonal, from this point to this point, this is called diagonal. Opposite faces, this is one face, another face, opposite corner of the cube. So they are asking to find for you resistance between A and D. So that is what they are asking. So here KVL to loop A, B, C, D, A. A, B, C, D. See, current is flowing through this I, and when it comes to this junction, there is a point A, there will be three branches dividing. So I by 3, I by 3, I by 3. Right? Then further the current is going and have again two branches to divide. So I by 3 divided by 2, it will become I by 3, this 2 will go up 2 by 1, so you will have I by 6. So that is what here I by 6. I hope the concept is getting clear for you. How this getting? Since it's a 3 branch, the current is divided by 3, I by 3, I by 3, I by 3. And again the current is going to this B node. Again there's two branches getting divided. So half of that, I by 3 half is I by 6. Okay. Then again it is going through one node, so it will get combined. I by 6, I by 6. I by, sorry, I by 6 plus I by 6 will be LCM. 6 is the same, 2 I will come, 2 ones are 2 threes are, so I by 3. So here comes I by 3. So I hope you are getting this KVL, this loop, how the current is dividing on the resistor each and coming to up to point D. So applying KVL loop at ABCD, ABCD A, it is equal to V is equal to, here V, this is minus. So while applying KVL, see now you see the how I am applying KVL. Here see it. I will explain here itself for you, so that you need not to get confused. So this is a plus. Once you see the plus, so first battery term you should take as minus V. So many books they won't explain like this, so I am explaining clearly for you. Minus V. Minus V if you take, then it's coming as plus I by 3 plus I by 3 into resistor 1 ohms. Why 1 I by 3 into 1 ohms? Because we are writing KVL, current into resistor. This is the current into resistor. Then plus, next in a point B also, I by 6 into 1 ohms, that is current into resistor. Then again plus, current is flowing through this, then again coming here. So when current is entering, you have to take this is plus and this is minus. Then again this is plus, this is minus. It's plus, this is minus. So again 1 by 3 into 1. So you will have a, this is the up to D. Then KVL is applied. Then this minus we would take other side. V is equal to 1 by 3 1 plus 1 by 6 1 plus 1 by 3 1. And if you calculate, sorry, this is not 1 by 3, this is I current, I by 3. Then you have 1 by 3 plus 1 by 6 into 1 by 3. This is V by I. I you are taking cross multiply this. So you will having V by I is equal to R. Then you are having LCM is 6, resistor is 5. So R is equal to 5 by 6 ohms. So resistance R by 6, 5 by 6 into ohms. So you need to have to take the things in a proper way. So in a competitive examination, you should do, this is the method of this everything, but in competitive exam, you should not do this much of calculation and all. Very simple. This type of question comes, you to give them to find the resistance means 5 by 6 into R. This R given value in question. Given value in question. Here it is 1 ohms, so you will have 5 by 6 into R is 1 ohm, so 5 by 6 ohms. So this is the answer is A. Suppose it is in 6 ohms, then 5 by 6 into 6 cancel 5 ohms like that. So what are the value they are given, you should just multiply by 5 by 6, that's all. So this problem will get solved. So for a better explanation purpose clarity, I have given this much. In a competitive exam, you need not to do this much questions. Next, moving ahead to delta connection network, which is star equivalent is shown in the figure. The resistance of R1, R2 and R3 below respectively. So this is the resistance we have to find in star network. Okay, so star network. I hope video is getting too length, so I am stopping this. Next video I will complete this everything, and I will proceed you coming up things so that you have a better idea. Kindly like and share and support me. So I am making this the first video. Any error, any mistake, any suggestion, kindly comment on the comment section. I have given my number to contact you, Telegram number and WhatsApp number. So eat well and take care. All the best for your exam. Thank you.